So today we are looking at angle pair relationships. This is technically our last section for this chapter. We'll expand on this in class a little bit more tomorrow by just looking at what happens when two lines intersect. So I'm going to go ahead and get my line tool here, and I'm going to draw one line here, another line going opposite direction and intersecting. Now what I want you to notice is that we have four angles that are created, angle 1, 2, 3, and 4, to make it a little easier. So today we're looking at the relationship between these four angles, and we have some special names and some special properties that we can apply that would happen to any one of these intersecting lines in these four angles created. So the first type of angles that we'll look at are what are called vertical angles, and these angles are formed again when lines intersect, and they have some unique properties about them. So let me go ahead and show you again with a line here. So I'll draw some intersecting lines, and again in your notes go ahead and draw these as well. Now you can see the definition that vertical angles are opposite angles formed from two intersecting lines. So from looking at this diagram, the opposite angles are, for example, 1 and 3. Those are vertical. So angle 1, and that's an and symbol here, and angle 3. Now my other one, okay, is going to be angle 2 and angle 4. Those are my pairs of vertical angles. So let's look at angle 1 and angle 3 first. So we can see angle 3 is here, angle 1 is there. If you had to say something about their measurements, what do you think you could say about their measurements? We'll look at that in a second. Same thing with angle 2 and angle 4. If you look at the measurement between those two, hopefully you can see that angle 2 here would be exactly the same as angle 4. Angle 1, this bigger obtuse one, is the same as angle 3. So one big thing about vertical angles that you'll need to know is that vertical angles are always going to be congruent. They'll always have the same measurement. And that's one of the big takeaways for vertical angles. Okay. So the other type of angles that are going to be formed, what are called a linear pair. So again, let's break down what this word really means, or these two words. Linear, again, is always going to mean a line. So line is right in it, linear. Pair is two. Well, with that definition, it makes it really easy to identify what linear pair is. It's two angles that form a line. So linear pair is slightly different. We're not looking at angles that are opposite one another. We're looking for angles that are adjacent or next to one another. Okay, and you can see that word right here, adjacent. We'll look at that in a minute, but again, I have a special definition for those. But they're next to one another. So an example of linear pair, angle 2 and angle 3. If I were to add these two together, angle 3 is an obtuse angle, angle 2 is here. Notice it's going to make a 180 degree, a straight angle. Another one we'll do is angle 1, angle 2. Again, same thing. Add them together, they make a nice 100 degree angle. Angle 1 and angle 4. And angle 4 and angle 3. And again, any two in these intersecting lines here will add together to make 180 degrees. Okay, so you might have wondered what that word adjacent means. So on the next, that adjacent angles are two angles that share a vertex and a side. So I'm not even going to go ahead and, we'll draw some of these here. So here's a few different measurements or angles in there. So I'm going to have angle A, or point A, point B, point C, point D, point E. So if I'm using letters and I want to just look at adjacent angles for now, again, I'm just going to say that angle ABC and angle CBD are adjacent. And by saying that, again, we're saying that they share a common vertex here at B, which you can see that they do, and I named them both with a B in the middle. And not only that, but they share a common side. The side that they share is here. So I may ask you what their common side is if they're adjacent. These two have a common side of ray BC. That is their common side. And again, these are a linear pair as well, in addition to being adjacent. Now, two angles don't have to always be a linear pair in order to be adjacent. So for an example, let me see if I can get this up here. So I'll draw a few rays. I'm still in my red. That's all right. Okay, we'll draw them close together here. And we'll draw another one here as well. Okay, so if I had this angle, and I wanted to put some points on here, so I'll go ahead and put in some letters, and I'll use my pencil. So I have point, we'll just stay consistent, point A, point B, point C, and point D. Now if I asked you to name a pair of adjacent angles, notice there's nothing that makes a line, so it's not a linear pair. Adjacent just means two angles that share a vertex, and in this case it's going to be B, and a common side. Now there's only two real angles that are small in here that you could name. So for example, angle ABC and angle CBD are adjacent angles. And again, the ray that they have in common is that side that they share, ray BC. An easy way to think about that is if you think about a house that's on one property, a house that's on another property, you're going to share a side wall with somebody that's kind of both of your wall, so you could kind of look in the backyard and see they have that same side in common. Okay? Same thing with angles. So that's the difference between adjacent and linear. So lastly today I have two other words that we'll look at, and again we're still continuing our angle pair relationships. And as you can see from reading this slide, the first one is to look at complementary angles. Now complementary angles do not have to be adjacent, but they may. So as an example, I'll just draw one. Oops, that's not what I want to do. Let me go ahead and use my pencil here. Just go ahead and draw an angle here. So we'll assume it looks like a right angle. It's pretty close. Now if I were to bisect that angle, we would have two 45-degree angles here. Now if I add 45 plus 45, obviously it's equal to 90. So what I would say is that these two angles are complementary because they have a sum of 90 degrees. So really any two angles that have a sum of 90 are complementary. So if you had angle, let's say CBD was 80, okay, angle FGT was 10, I would say automatically these are complementary because again they add up to 90 degrees. Now there is a way to remember this. Again, a right angle is going to look like a corner. So if I was to take these two together and add them, they're going to make 90 degrees. The easy way to remember that is to think it looks like a corner. So think of what a corner looks like. C for complementary. Okay, and that's the easiest way to remember. Okay, complementary versus supplementary. Now, supplementary angles, very similar, but now two angles that sum to 180. So not to 90. So we look at two angles. We already said a linear pair would look something like this. So if we said, again, we'll just keep our numbers nice and simple here. If that's 80 degrees, this one is 100. We would say that these are supplementary because they add to 180. Now again, they don't always have to be adjacent, either complementary or supplementary. They can just look like two angles that you've kind of thrown together. Okay, so for example, if we say we got a 40-degree angle here, we can do a non-adjacent angle right with it. Okay, so let's see here. We can kind of throw that one in here as well. So that one's 140. I can say that these two are supplementary because they add to 180. And that's the big difference. Now, just like complementary, there's a trick to remembering this as well. Supplementary starts with an S. So does straight, like a straight line. And if you think about a straight angle starts with S, supplementary starts with an S. That should help you to keep the difference between complementary and supplementary. So that is a good stopping point. I know we've covered a lot with supplementary, complementary, vertical angles, linear pair, and adjacent angles. We'll continue to build on this tomorrow, so bring questions if you have them. Take some notes and fill out your WSQ form on Schoology, and have a good night.